Hi, good morning to you all. Let me introduce myself to you. My name is Kumar Muthuswamy and I am a senior enterprise data architect with 20+ year industry experience and expertise. I have helped the top clients in the technology, manufacturing, semiconductor, finance, retail, oil and gas to resolve many issues in data architecture during my tenure. I take pleasure in welcoming you all to this session. Today I am going to give you an overview of the architectural framework and building a modern big data platform for real-time BI and predictive analytics within few seconds, using Apache open source framework with the help of multiple data sources like Oracle, MySQL, NeoDB, MongoDB, web data, to data visualization. In this architecture, we are going to create real-time data insights, using canonical design of Lambda architecture, with the power of two parallel layers such as batch and speedy layers. This defines the efficient flow of data through multiple components for predictive analysis using the Spark predictive machine learning model. Here, predictive analytics encompasses a variety of statistical techniques from data mining, predictive modeling, and machine learning and analyze current and historical facts to predict COVID death counts. Let me give you a brief note on the process stage by stage. In the first stage, data is moved from its source to the data lake. Stage 2 is where the history data and the real-time data is captured from HDFS location and published to Kafka topic using Neofy tool. During the third stage, semantic layer is customized and the COVID-19 data is consumed from Kafka using Spark Python program. We are using this data for machine learning to predict future death counts. We have created a Spark streaming application for a continuous data stream from Kafka to Snowflake. In the fourth stage, data is visualized using Tableau and Matplotlib. Let me tell you, I am going to use web source for this whole demo. We see here about the data source of COVID-19 Johns Hopkins. The objective here is how the real-time data is visualized using Tableau. The data related to Johns Hopkins COVID-19 is streamed in real time and deployed on the Tableau dashboard. You can see here how the prediction data for CA keeps rising using machine learning for COVID-19 Johns Hopkins. As I mentioned earlier, I am using web source for this process, but we can also use the following data sources for this process flow. Stage 1, Data Lake. The below screen explains about the enterprise data lake process and the tools used for this process. Stage 2, Data Warehouse. The process for data warehouse and the tools used are shown in this. Visualization reports and user access. The purpose of this stage is to display the output and make this information available for the user. The tools used for these processes are shown in the screen. HDP environment. Here the demo shows how it is achieved by using HDP Hortonworks data platform with 1 master and 10 data nodes. Below is the version used for this demo. Now let us start running the whole process step by step. There are in fact multiple operations and programs needed to be run, and this has been explained in the below notepad. As the first step, the data is moved from its source to the landing area of the external table in the Hive using Python script. The files and the comments are cited below. Once we run the Python script, we can able to see that each file is processed and moved to the landing zone. The script will run every 1 hour to check for new data and insert the data into the landing zone accordingly. The landing zone is a Hive external table, where we can able to see once the data is moved to the Hive external table, the cron job ensures that the data is equal to the managed table by executing a query. Inserted data. Here NIFI is used to monitor and then to publish the changed data to Kafka. The workflow is now created in NIFI starting from Hive table CDC, which tracks the new files and send the information to publish Kafka record processor. Once the data is published to Kafka, this data will be consumed by Kafka Consumer to perform machine learning prediction. The files and the commands to be executed are shown in the display. Let us run the command to consume the data and use that data to train the ML model and run the prediction as well. The data is consumed and loaded to the data frame. Then the machine learning model is trained to generate the output in a chart form. Here NIFI is used to monitor and then to publish the changed data to Kafka. The predicted output is displayed using simple HTTP Python server. During the process of prediction, the Spark streaming code runs parallelly to the data streaming from Kafka to Snowflake DB. The files and the command to run the code is shown below. Here the data is started to stream to Snowflake to analyze and visualize the data. The below chart explains how the Tableau is used as one of the best visualization tool. Let us connect to Snowflake DB from Tableau using the ODB. We have come to the end of the overall architectural demo of the real-time enterprise data warehousing. Thanks for your time. I would really appreciate if you could send me an email with all your doubts and queries. This is my email address. I really enjoyed explaining all this to you and I hope you did the same. I once again thank you very much and wish you a great day. CC Connection.